Hey everyone, I am absolutely thrilled you're here. If you are gearing up to completely crush the AWS Certified AI Practitioner exam, you have definitely found the right place. Look, we are living through an unprecedented boom in generative AI right now. Companies are practically begging for professionals who can actually prove they know how to build, secure, and manage these systems in the cloud. And that is exactly what this certification proves you can do. Today, we're going to break down the most complex concepts, conceptually and visually, so you have a completely comprehensive guide for passing this thing. By the end, you're going to be able to walk into test day with total confidence. We've got a lot of crucial ground to cover, so let's just get right into it. But first, I gotta ask you a pretty serious question. Are you actually ready for exam version 1.1? Because if you've been studying old materials or, relying on outdated practice tests, you might find yourself in a total panic on exam day. See, on April 30th, 2026, AWS dropped a massive blueprint update that introduced some heavy agentic AI concepts. The whole exam shifted from just asking about foundational models to asking how those models take independent action. We're going to cover exactly what you need to know about this major shift so you don't get caught off guard when you sit down for the real thing.
Okay, let's dive into our battle plan for this study guide. First, we'll tackle the 2026 agentic AI shift. Second, we'll master Amazon Bedrock Essentials. Third, we are going to decode machine learning metrics. Fourth, we'll conquer AWS AI service selection. And finally, we will lock down security and responsible AI.
All right, Domain 1, the 2026 Agentic AI Shift. This represents the absolute biggest change to the certification, and you absolutely must understand the new realities of this updated exam blueprint. So there are three major new services explicitly in scope for version 1.1, and you really need to lock these into your memory. First up is Amazon Bedrock Agent Core. Think of this one as your ultimate command center. It's a unified platform where you build, evaluate, and connect AI agents right in production environments. Next is Kero. If you've used standard coding assistants before, Kero takes that to a whole new level. It's AWS's new agentic coding service, and it functions way more like an autonomous AI pair programmer that can independently navigate entire code bases. And finally, we've got AWS Transform. This is the agentic modernization service. Imagine a tool that acts like a migration wizard, specifically designed to read, refactor, and migrate heavy enterprise workloads completely automatically. These three services, they are the core pillars of the 2026 exam update. Before we go any further, though, we really need to unpack a crucial definition. What exactly makes an AI agentic? Well, think of a standard prompt response model like a highly intelligent encyclopedia. It can write an email for you if you ask it nicely. But an agent? An agent actually orchestrates actions. It's an AI that can write that email, autonomously open up your email client, fetch the right contact from your database, and then actually hit send. It reasons, it creates a plan, uses tools, and knocks out multi-step tasks all on its own. Now, the exam is also going to test you on the Model Context Protocol, or MCP. MCP is simply the open standard used to give these agents safe, secure connections to your external systems and data sources so they can actually do their jobs. Now, it is absolutely vital to contrast two of those new services, Kero and AWS Transform. The exam loves to throw a business problem at you and see if you know which tool to pick. You are going to choose Kero for agent coding scenarios. Kero uses these highly structured artifacts called specs and steering files to formalize feature development right inside your developer workspace. It's all about building net new features or squashing bugs. On the flip side, you choose AWS Transform when the scenario involves migrating massive legacy enterprise workloads. If a question mentions moving ancient mainframe applications or maybe modernizing a sprawling .NET architecture to the cloud up to 4 times faster, AWS Transform is your undisputed answer.
Moving right along to our second section, Mastering Amazon Bedrock Essentials. This is some heavy-hitting material, and it is exactly where the exam loves to test your knowledge of very subtle feature differences.
Let's highlight what I call a golden exam distinction. Seriously, if you take away just one thing from this entire explainer, let it be this exact concept. The exam will constantly try to trick you into confusing RAG with fine-tuning. Here's the golden rule. RAG changes what the model knows at request time. Think of RAG as an open book test. The AI doesn't need to actually memorize your company's constantly changing HR policies. It just retrieves the latest document and reads from it, giving you exact citations. Fine-tuning, on the other hand, changes how the model behaves. Think of fine-tuning like sending a doctor back to medical school for a new specialty.
You use it when you need to permanently enforce a very consistent writing style, tone, or deep, specialized task behavior that the base model just doesn't understand out of the box.
Let's look at another highly tested pair, agents versus knowledge bases within Bedrock. Picture an exam question where a user interacts with a chatbot. They ask the bot to cancel their upcoming flight and rebook it for Tuesday. Because the system actually needs to execute an API call and make a transactional change in a database, you absolutely need an agent. Agents act. But if a different exam question says the system simply needs to search indexed company documents to answer an employee's question about their PTO balance, providing citations without changing any data, you choose a knowledge base. Agents execute, knowledge bases retrieve. It's that simple.
We also really need to understand how a knowledge base actually works under the hood, because the exam frequently tests the exact order of operations in a RAG workflow. First up, you store your raw documents. Then you perform a step called chunking. Think of chunking as taking a massive, heavy textbook and chopping it up into individual paragraphs so it's way easier to digest. Next, you convert those chunks into numerical embeddings. This just means turning human words into GPS coordinates so the AI can figure out which concepts live close to each other. You store these coordinates in a vector store, and then when a user finally asks a question, the system searches those coordinates to retrieve semantically relevant chunks, passes them to the foundation model, and generates a beautifully grounded, accurate answer.
All right, deep breath. We are entering Section 3, Machine Learning Metrics Decoded. I know, this can feel like a really dense mathematical topic, but we're going to make it highly visual and super easy to stick in your brain. The foundation of classification errors lies in the confusion matrix. Let's ground this in reality with a fraud detection model. A true positive, fantastic. That's fraud correctly blocked. A true negative is also great. It means your legitimate grocery purchase went through. But errors happen, right? And they have very different costs. A false positive is the model panicking and declining your card at a coffee shop just because you traveled out of state. It's annoying and embarrassing. A false negative, however, that is a disaster. That's a hacker successfully buying a jet ski with your money while the model stays completely silent. We need specific metrics beyond basic accuracy because in datasets where fraud is rare, a model could just guess not fraud every single time, boast a 99% accuracy rate, and completely fail at its actual job.
And that brilliantly illustrates why we use precision and recall. Precision protects against false alarms. It minimizes those false positives. You want to prioritize high precision when falsely accusing a transaction of fraud is highly costly to your customer's trust. On the flip side, recall retrieves the real positives. It minimizes false negatives. Think about a medical AI designed for cancer screenings. You want exceptionally high recall there because missing a real threat, a false negative, is incredibly dangerous, even if it means you accidentally flag a few benign scans along the way. Precision for avoiding false alarms, recall for catching every real threat.
Overfitting versus underfitting is another classic exam staple. Overfitting is essentially memorization without generalization. Imagine a student who just memorizes the exact answers to a practice test, getting 100%, but when they sit down for the real exam and the numbers are slightly different, they fail miserably. The model's training performance looks incredible, but its validation performance on new data is terrible. Underfitting is the exact opposite. It simply means the model hasn't learned enough to understand the patterns at all. It's like the student who didn't study whatsoever. Both their training performance and their real-world validation performance are equally poor.
Fantastic job sticking with me so far. Let's shift gears to Section 4, AWS AI Service Selection. This is a classic exam scenario where you have to map the exact right tool to a highly specific business problem.
The absolute secret to acing this part of the certification is treating it purely as an input-to-output matching game. If the question gives you audio as the input and wants text as the output, the only answer is Amazon Transcribe. If it gives you text in English and wants it output in Spanish, that's Amazon Translate. What if the input is a scanned image of a medical document and the output needs to be extracted text? That's Amazon Textract. Guys, do not overthink these questions. Ignore the fluffy business context they wrap the question in and strictly follow the input-to-output pipeline to find your answer.
I want you to lock in these memory phrases right now because they will save you so much valuable time on test day. Amazon Recognition recognizes visual content. It analyzes images and video. Amazon Poly speaks. It turns text into incredibly lifelike speech. Amazon Comprehend understands text. It reads documents to extract key insights, entities, and emotional sentiment. And Amazon Lex conducts structured conversations. It's the engine for building chatbots using intents and utterances. The exam also really loves integration questions.
For instance, if you need a customer service bot that can talk out loud to a user over the phone, you would seamlessly combine Lex to handle the conversation logic and Polly to speak the responses back to the customer.
And just like that, we have reached our final domain, security and responsible AI. Now, I have to warn you, this section contains some of the trickiest exam traps regarding governance, safety, and determining exactly who is responsible for what in the cloud.
First up, let's clarify a very confusing pair: explainability versus transparency. Explainability answers a highly specific question. Why did the model produce this specific result? Look, if your AI denies a customer a mortgage and you can't explain why, you might get sued for algorithmic bias. Explainability is peering into the black box. Transparency, on the other hand, is much broader. Transparency answers what AI system is being used, what data does it rely on, and what are its overall limitations. Failing at transparency means your customers don't even realize they're talking to a bot in the first place, or they don't know how their data is being handled.
There is a core mantra you absolutely must remember for the shared responsibility model. AWS protects the cloud, the customer protects what they put in and configure within it. When a question asks who is responsible for the physical security of the data centers running Amazon Bedrock, that is AWS. But AWS just gives you the tools. You, the customer, are entirely responsible for encrypting your proprietary data, correctly configuring your identity and access management permissions, and heavily monitoring the prompts your users send and the outputs your models generate. Okay, listen up, because that brings us to a massive exam trap. A question will describe a scenario where a company wants to block sensitive, personally identifiable information, PII, from being sent by an employee into a generative AI chatbot. One of the multiple choice options will be Amazon Macy. Do not fall for it. Macy is an amazing tool, but it only discovers sensitive data resting quietly in S3 buckets. It is not a live, real-time prompt filter. For active live prompt and output filtering in a generative AI application, you absolutely must explicitly select Amazon Bedrock Guardrails, which actively monitors the conversation mid-flight.
Finally, let's talk about data lineage. This is an absolutely critical responsible AI principle. Lineage records the entire life cycle of your data. Where did it come from? What transformations did it go through? Where was it ultimately used in training? Auditors care deeply about this. If a machine learning model starts spitting out horribly biased or toxic outputs, you need data lineage to trace that behavior all the way back to the exact piece of poisoned training data that caused the problem in the first place. It is the backbone of reproducibility and accountability in AI.
We have thoroughly covered the agentic AI shift, Bedrock essentials, ML metrics, service selection, and the critical security traps of the exam. You've got the map. You know exactly where the pitfalls are, and you have the analogies to make these concepts stick. Take these strategies directly into your final study sessions. But I want to leave you with a bigger thought here. Passing this exam is really just the beginning. As agentic AI moves from theory to taking over massive enterprise workloads, the real question isn't just whether you can pass a multiple-choice test. The question is, are you ready to architect the autonomous systems of tomorrow? Are you ready to build the future? Keep reviewing these core concepts, stay curious, and best of luck on the exam.